Okay, so chapter 16 is the new focus. We cover this part of the book, take a test, and then we're going to skip to some other part of the book, and that will be our last activity for the semester.
You said this would be chapter 16?
Yeah. 16. It's going to be sample space. So a place to start is talking about an experiment. An experiment is any process or activity in which the results are uncertain, so in which the results cannot be predicted ahead of time. See, we'll say whose results. For an experiment, we call these results outcomes. So we could say any activity whose outcomes cannot be predicted. Okay, ... outcomes. So this part is kind of like the universal set. It's the set of all outcomes, but when you talk about an experiment, it has a new special name. So it is a universal set, but for experiments, we call it the sample space. The sample space. All right, last thing to define today, and then we'll just do examples, is a subset of the sample space is called an event. Oh, also, we like to call the sample space S. The sample space of all sort of outcomes. The sample space S. Here, capital S. So kind of like capital U, just specific to experiments. Any subset of the sample space is an event. So I'm just going to give a sample space for the first example. Let's say that this is some experiment, and the sample space just has the numbers 1, 2, 3. Like maybe it's a hat, and inside are pieces of paper with the numbers 1, 2, 3. Depending on which number you draw, certain things occur. Just trying to set up some kind of experiment. Let's call event, capital E, will equal the set that contains 2.
When you're talking about the sample space, is that taking into account the amount of those type of outcomes in say there's like 5 1s, 3 2s, and 7 3s in a hat? When you're determining S, is that just saying the only options you'll get are 1 2 3 without taking into account there's a looking at the probability? Like when you're determining sample space, is that just saying these are the options? It does, but it isn't telling you how many of each are in the bag. Does that question make sense?
It does. Actually, I think if you wrote out the sample space, you would put like maybe each one, like 1A, 1B, 1C, depending on how many ones there are. But let me think about this. I know kind of, well, like, let me make a similar example, sort of on what you're talking about, but then I'll have to look into maybe other situations to see. Like, let's say a bag contains 2 red marbles. I think it's LES. Also 3 blue. You would, well, I would use R, do capital R for red, and have R1, R2 for each of those red marbles. And then for the 3 blue marbles, we'll do capital B1 is the first blue, and then B2, and B3.
That does answer my question. If it helps, if you don't have to go. You said if you had to search, for the different answer. What I was asking, actually, that did answer. Awesome.
Okay. Yeah, the thing that I'm thinking will happen soon is when we later on, like next class, get to probability. Then we don't need to kind of split everything apart, but when we actually talk about the whole space, we'll like
Right.
everything. Okay, there's some classic ones. One I would say is to flip a coin. So example, flip This tree diagram helps, but you don't have to draw the picture. But you start somewhere and you branch off, and your possibilities are heads. Start. You could get tails. Okay, so that's just one flip. And we'll put the sample space. set of all possibilities. This time it's only possible to get heads or tails. Heads or tails. Let's call that A. Okay, the event that the coin lands face up, or the event of getting heads. I'm going to stick with calling our events E. So capital E is event, and it equals the set that contains lands face up, just this outcome, heads. So we have a fair coin and we flip it twice. Flip a fair coin twice.
When you say fair, you just mean like it's not one of those, say, like a magic one where it's either a double head, double tail, or like weighted on one side, right?
Yeah.
Like a standard, like
50-50.
quarter or whatever. Yeah.
Yeah, exactly. I like that word not weighted. So, or like unbiased. So, twice. So we'll draw a picture and then list the sample space. So first flip can be heads or tails. Okay. From each of those possibilities, there is either heads or tails or heads or tails. So branch off and H, T, or here. Oh, H or T. Okay, you get all possible outcomes by following the branch to the end and then get every single branch. S. Find the sample space. S. So you could get heads then tails, H, 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 T. Or you could start with tails and then heads. Last one, tails, tails. Let's find the event of all tails. Or like lands face down, both flips. Oops. Okay. We like to call our events E. is a subset of the sample space. So you start your set, and we want lands face down both times, right there, tails, tails. That's all you put into the set. So this means tails on the first flip, tails on the second flip, and this is one possible outcome, like as a little pair from your sample space. Let's do one more question about this set. I have, what is the event of getting at least one heads? Okay, at least one H. So we can use, this has at least one of them. So does this one. So does this one. We can't use that last part. So HH, HT, TH contained in the set. Right over here. We're going to do 3 flips and then kind of move on to some other experiment. So we flip a fair coin 3 times. All right, we're going to list out all possible outcomes and then put them in a set. That will be the sample space. We'll draw another tree diagram. We go start, flip 1. Can be heads or tails. Then from each end, you can do flip 2. Could be heads, tails. Here you could have heads or tails. All right, from all of those ends, heads or tails, same, heads or tails. This. Branch out, H, T, again. Last time. So we have to work through each branch and get to the end. We're going to have 8 total outcomes in the set, in the sample space. I'm going to just make really big brackets. H, 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 all heads in a row. Heads, heads, tails. Heads, tails, heads. Heads, tails, tails. That's the first 4. So let's go here. Tails, heads, heads. Tails, heads, tails. I still have some more in this set. And also, I would like to list them all out just because I've run out of space. We're here at tails, heads, tails. We need tails, tails, heads. And all tails at the end. 1, 2, 3, 4, 5, 6, 7, 8. We will do part B will be find the event of exactly 2 tails. Our events we call capital E, and it equals this set that contains. Well, I think we'll circle everything first. So right here's the first place where there's 2 tails. And this has 2 tails. And this has 2 tails. Tails, tails, tails. Tails, tails. Tails, tails, tails. Let's do okay, what is the event of no tails? Okay, we will still call it event E. If we were talking about the same problem, we could just pick another letter, like capital F would be fine, or we could call it capital A. It's okay. Let's call it capital A, just because it's not a big difference. We'll say event A is the set, no tails. Right, that's only right here. Heads, heads, heads is the only place where there's not a T involved. So if it were homework or a test and you want to call it E, that's fine. But just because I've already got a set called E, I just called it A to show that it's different. All right, we'll do something new. So our new experiment is to roll a fair die. Or roll an unbiased die. S is going to be the faces on the sides of the die, and we're just going to have that represented by 1, 2, 3, 4, 5, 6, each face. Okay, find the event of rolling an even number. We're going to call it capital E as our event. Equals the set that contains the set 2 and 4 and 6. find the event of rolling a number less than 4. So I've already used capital E. I'm going to change it up and call this capital F, and capital F is the event that contains numbers less than 4. So I can't use 4. I can put in 1, 2, and 3. And I think we'll just do one last piece to this example and call it good. So let's do the event of rolling a number greater than or equal to 5. Well, we can list it first. I do want to draw a picture because you could have drawn a picture for all of the other examples we did. A Venn diagram type of picture. Okay, this event we'll call event A, and it's the set that contains 5 and 6. So we'll draw a lot of these next time when we talk about probability, but the whole set we call S, capital S, sample space. We will put A as a subset of S, or A is an event inside of S that contains 5 and 6. Other possibilities from rolling a fair die were 1, 2, 3, 4. We already have 5, 6. Okay, so next time we'll do like probability of A, the probability of not A, things like that. But for now, please work on your test. Let me know if you have any questions or concerns. Thank you, everyone.